In this video, we're going to look at factorial notation. So it's just a notation that's going to prove to be really useful when we're thinking about permutation and combination problems. So factorial notation is this sort of thing. If I write 5 followed by an exclamation mark, that just means 1 times 2 times 3 times 4 times 5. So it's the product of all numbers or all positive whole numbers up and to including the number in question. Now obviously we don't need to bother with a 1 there, I just put it in for completeness to show that it is the product of all the numbers up to that point. So in the case of 5, this turns out to be 120. So they grow pretty quickly. Let's just do 6 factorial. So 6 factorial would be 1 times 2 times 3 times 4 times 5 times 6, which is going to be 720. Now, that's it for the definition. There's just one little thing to show you before we look at some nice problem-solving questions, which is, what about 0 factorial? Okay, 0 factorial is a term we have to deal with. Now, I'm going to come to what the answer is to this in a second, because it's slightly strange. Here's a way to think about it. Suppose I was to work out 1 factorial. Well, 1 factorial is just 1, so that's easy. 2 factorial, well, that's 1 times 2, which is 2. 3 factorial is 1 times 2 times 3, which is 6. 4 factorial, 1 times 2 times 3 times 4 is 24, and so on. We've already worked out 5 factorial. That's 120. So let's think about a pattern here. Well, to get from 120 down to 24, what do I need to do? Well, the difference between this and this is that this one is 1 times 2 times 3 times 4, and this is 1 times 2 times 3 times 4 times 5. So you multiply by 5 to get this way, and you divide by 5 to get this way. Okay, how do we get from 24 down to 6? Well, we divide by 4, because this was 1 times 2 times 3, and the 24 was 1 times 2 times 3 times 4. Okay, the pattern continues. We divide by 3 here. We divide by 2 to get down here. And we divide, therefore, by 1. And 1 divided by 1 is 1. So 0 factorial is 1. Now that one's a little bit strange because it doesn't really follow the rest of the pattern in terms of our definition, because if you start at 1 you can't get to 0. So it's a little bit unusual, but 0 factorial is going to be 1. Okay, let's have a look at a couple of problems. So calculate the value of 20 factorial over 80 factorial. Now, this is something you could work out with a calculator, but I want to show you how to do it without. Now, for a start, 20 factorial is absolutely enormous. It's about 1 billion times 1 billion, so it's a huge, huge number. Now, the calculators obviously can cope with that, but I want to show you ways to do it without. So, what does 20 factorial mean? Well, 20 factorial means, and don't worry, I'm not going to write out all of these, 1 times 2 times 3 times everything all the way up to 20. So let's just put the last few numbers, times 17 times 18 times 19 times 20. And that dot, dot, dot just refers to all of the numbers in between. Now, what about 18 factorial? Well, 18 factorial is 1 times 2 times 3 times dot, 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 all the numbers up to 18. So what you can see here is that there's loads of numbers that cancel. We can cancel the 1, so that doesn't really make a difference, but we can do it. We can cancel the 2s, we can cancel the 3s, we can cancel all of the numbers represented in the dot, dot, dots, we can cancel the 17s, the 18s, and the only 2 numbers that survive are the 19 and the 20 on top. And 19 times 20 is 380. So you see we can actually find the value of that nice and easily without using a calculator. Okay, one more problem here. Now, if you're feeling confident, do pause the video and have a go yourself. Let's just work each of these out individually. Now, using the same logic as we used before, we've got 1 times 2 times everything up to 12. I'll just include the 10, the 11, and the 12, divided by all the numbers up to 10, 1 times 2 times everything up to 10. And then for our 11 factorial over 9 factorial is 1 times 2 times everything up to 11, 9 times 10 times 11, and then divided by 9 factorial is 1 times 2 times, and then everything up to 9. So this one here, everything cancels apart from the 11 and the 12, so I just get 11 times 12 here. And then for this one, everything cancels apart from the 10 and the 11. So we have 11 times 12, which is 132, and 10 times 11, which is 110. Add these together and we get 242. So that's an introduction to the factorial notation, which is, as I said, an essential tool for probability questions and permutations and combinations.